Welcome. Today we are going to study on what binary classification with the heart disease data. Okay, so we wanted to study the heart disease data. So we have to input our pandas as PD. When we do that, the second thing is that we have to load our data. Df is equals to PD dot read. We tell pandas to read our what our CSV data is in CSV format. Okay, so read this as raw data. Come here, you copy as part, you come, okay, paste it there, you run it, what's happening, PD, okay, we made a mistake here, remove this F, okay, run it, call now the GF, this is our data, and we there, so with this our data, we have now what, first and foremost, we have to look for the non-value, none, where you see none, so there are non-value, okay. So I want us to drop the non-value. Look at it, there's none here, none. So how can we do that? Let us call tf equals to tf dot drop none. Equal tf. Okay. Now at this point we have dropped the non-value. That is why if you look at here we are having 302. We have non-value. Okay. At this point we have the 301 and that 302 is not there. Have you seen it? But here it was there. 302 was there. So we have dropped that non-value. We have dropped that non-value so that we are going to work our data well. Okay. After we drop the non-value, we have to do what again? We have to place our data now into what? Into categorical form. Okay, we have to categorize our data because machine do not understand this word. Typical machine always love to understand the numerical word. All these words like this fixed or machine do not understand. So you have to place the data now into categorical data. So how do we need to do that? We have to, there's a term that we call it one hot encoding. One hot encoding. Okay. You have to use one hot encoding. On one hot encoding, you have to do on that categorical data called GF. Now on GF now, we need to look now on, we need this chest pin, okay, to place chest pin on categorical data. GF chest pin is equals to what? Okay, GF, and just copy this, equals to GF, the same chest pin, then dot as type, okay, the same chest pin dot as type, as type, then we place it, the type is category, okay. So let us first of all test it and see. We have an error there. So if you see this, obviously we have not completed it. Now we have to complete it, copy this and paste here. The f dot bin equal the f dot now at this point of as type, you then now remove it and fit dot card category dot category code, category code, we run it, we call the f Okay, at this point we have worked it. Now if you look at it very well, the chest pain now we have placed in the chest pain into categorical data. You look at it now, you have these are 3 0, these are categorical data. So it is not only this one, we also have again another this other one again, tie. Okay, we have to place this tie also into categorical data. So since we already write this code, let us just copy this code up there and paste it down here. They will change now this name of chest pain into tie. Okay, we copy this. We will just move this part, move this part at the point of chest pain into tie. The good news is that this thing is just easy. It's just good for you to understand the concept. Okay, then you run it. When you run it, you realize that at that point of tie, it is now also a categorical data that they are placing into numerical data. Okay, so we have now all this now. So we have changed now our data now into what? Categorical data. So we move to the next. Okay, now when we do that now, what is still left? We have what? No. AHD, no, yes, no. So this point also we have to change it also because computer will not be able to understand this. So we have to change it also into numerical listen. So also convert it to categorical data. So this one now, at the point of no, no, it will be 0 and at the point of yes it will be 1. So change it back. So we still have to use this our same copy this, just copy it. Yes, is this same code experience? Just copy this. Then now we have to change the word AHD, right? Just come at this point of move this part, paste it here. Okay, we are not in the S. Move this, paste it. When you do that, okay, then you run it right there. So now when you run in now, you have now at the point of AHD, you see 0, 1, 1. So we have now changed all of them now into categorical data, so we can move forward. We have to look for null value. Okay, so looking for null value, we have df dot is null. Okay, df dot is null dot sum proof. Okay, okay, showing that we have this no missing value. Okay, because we have cleared it there. Then we have okay, now we call x this column. Look at our data very well. Our column AHD. Okay, this is a column that we have to predict. Okay, so we have to use all this as our x variable. Then only this column is our y variable. So what are we going to do? We have to use now this code that x is equals to what? Df f dot drop is a drop. Okay, column is equals to now. Just need to do what? Just copy this column. I wanted to drop this column. Okay, copy the column here. Okay, so when now we call x, we realize that x, that this column, the column of AHD is not there. Because why? We have dropped it. So x contains now this other one. Okay, now let us go now for y. Y is equals to what? Gf y is only EAD, right? F of EAD. So we'll call y give us what? Y is only on our AAD, and our AAD is the yes and no. So this is what we wanted to predict. Okay, so we move forward. We have to train the model. Train the model. Okay, for training the model, we use scaling for training the model. So we set also train. We have to train the model. So say from s lin dot model from scaling dot model. We set select, okay, the model selection, import train, train test test split, purchase test split. So when we do that, our train test split will use x and y training. Okay, so for x train, x train, x test, x test, y train, y test is equals to what? So you just need to copy this train test split. Okay, train test splits. We have what? X, comma, y, y, comma, test, test size equals to, let's say 0. That's 30%, 0.3. Okay, 0.3, comma, have random state state is equals to, let's say, is it 25. Okay, that we call x train, x train, x train. Now with our x train and y train. Okay, see this. You see our y value is different from y train, so you should know about it. Is y equals 0, 1, but now y train is different. Okay, look at 1, 0, 0. So now we move forward. We have to do what? If you look at now the various value, we have what? Bigger value, smaller value. So we have to work on to scale them, okay? To scale them. So what are we going to do? We have to look for standard scaler, standard scaler, scaler. This standard scaler, if you go to Google, you type standard scaler, scaling, you will realize you see standard scaler scaling, you click on it. So this is how it is. A class scaling process. Okay, this is the formula. Okay. So what did they do? Standard feature by removing what the mean and the scaling to the unit of variance. So this is the standard scaler. Okay, so you can read all through on how it functions. Then move forward. You know that standard scaler, that Z, the Z that we see there, this Z is equals to what? The data minus the mean divided by what? The standard deviation. Okay, the data minus the mean divided by what? Standard deviation. Take note about that. Okay, since we have what? Bigger data. This always occur when we have bigger data. Like bigger data, like you have this one is too big, this one is too small, so you have to do what? To standardize it. So that is the reason that we're using standard scaler. So we have to use our formula from scaling, scaling, scaling dot preprocessing input standard scaler. When you run it, then we have what? Or X-train scale, X-train scale is equals to what? Scalar dot fit, scalar dot fit train, scalar dot fit train X train X train. Yes, well, before writing this, let us insert scalar. Scalar is equals to this one, standard scalar. Okay, scalar equals to standard scalar. We run it, then from there we run our. So we have X test X test X test we omitted it was X test scalar is equals to scalar dot transform X test test. Okay. Okay, now let's let move forward. By import, we have to import logistic regression. Okay, import logistic regression. Oh, sorry, we see from scaling dot linear model. Import logistic regression. Okay. After we import logistic regression, we call logistic regression log equals to logistic regression regression equals to logistic. Just copy. Don't just copy here. Okay. Logistic regression equals to logistic regression. Random state. Random state equals, let's say, 0. Then let us fit dot fit what or x string fit x string fit x string scale. This one you can just copy it. Okay, x string scale and y string comma and y string. The y string. Now we have to predict use logistic regression. No, predict x string scale x string scale. Okay, as we launch the program, let's verify we're using score. Okay, logistic regression dot score. The score, just copy this. Okay, score of x string scale bracket y train. Okay. Our S train scale has 0.87. It's not bad. Let's look at the logistic extents, logistic regression dot for the score of X test test scale scales and Y test. So now to recap on what we have done from the beginning, we scroll down. So we say that we are working on binary classification with heart disease. So we import our data from there. We import the data. This is our data. And what do? We are able to remove the none by doing what? Writing a function, a code, tf the job none, we drop this non-value. After when we do that, the next thing we have to do what? To remove this value and replace it with what? Numerical value, because at the end, our computer does not understand, the machine does not understand this value. So we want to place it into numerical value. So how do we do? This is it. We write the code on that. After that, we realize that chest pain has a numerical value at this point. We're still having another value again that we have to change. This tie and AHD. So we move ahead and remove the tie. When we remove tie at the end now, it was what? Changed to what? Numerical value. What was left was AHD. We need to change this one also because we were moving, changing now what to numerical value, and it is become what? A categorical value. Okay. So now when we change it, we write the code AHD. When we change it, it become now 0 and 1. After when we did that, we look for what? The null value, and there was no null value. Later on, we move forward to separate it x value and y value. So our x value, it means that what? We have removed AD is our predicted value, AHD. So x, that is why we say x dot drop. We drop the column of AHD. That is why here you don't see the column. Then we move ahead. We use what? Y. This is our predicted value, y. Then we happen to look at the y. How is the y like? This is a y. Later on now, we train the model by calling what? From scaling, using scaling to train the model, import train test split or import chain test split. Now at this point, the size is 30. Okay. Then random scale state is 25. If you don't place a random scale, anytime that you run it, okay, it will change. Anytime that you run it, it will change. Okay. Then X train, we call the X train, call the Y train. Then from there we do what? Use standard scaler. Why do we use standard scaler? It was because here we have bigger value and smaller value, so we have to scale all of them. Okay. So now when we use standard scaler, it is going to scale now all. Now we call now from scaling process import standard scaler or import standard scaler. We import standard scaler on what? X train and X test. Okay. Then X train, now we feed it now on what? X train, and we transform it on X test. When we did that, we import regression from scaling. We use linear regression. From there, we call logistic regression random state to fit. We transform. Later on now, we look for what? The score. Here our score is a bit encouraging, 0.87. Then we finally look for what the score at X test, because this is a score at the train test, and this is score at what X test. So we are going to end there. So in the next part we are going to continue. So if you find this video useful, make sure you subscribe so that as we are continuing, you will be updated with all the information and the new video that we are going to upload. If you have not liked this video, make sure you like and put the thumbnail. We'll move forward. Thank you very much. See you. Bye. Take care.